In this video, I am going to introduce you to mathematical expressions. Let's begin. So we're going to start off with some definitions. A numerical expression. A numerical expression is a mathematical sentence that contains numbers and operators. Now, operators are things like plus and minus and times and division. So examples would be 1 plus 1. Another would be 1 minus 2 plus 3. Another one could be 5 times 3. Another could be 10 divided by 2 plus 5 minus 1. Now, you can also have a one-number expression like 3. 3 would be a numerical expression as well. And notice I have all sorts of different operators. I can have minuses or pluses or divisions or times. All of these are considered numerical expressions. Now, contrast that to equations. An equation is also a mathematical sentence, but it includes an equal sign. So how is that different from a numerical expression? Well, 1 plus 1 equals 2. That would be an equation because it has an equal sign. And notice I have to have like a number on the other side of the equal sign. I can't just put 1 plus 1 equals. It has to have something equal on the other side. Another example would be 5 times 3 equals 15. Another would be 2 equals 10 divided by 5. Now notice you don't have to have two numbers on the left side or three numbers on the left side. The numbers can be on either side as long as it is equal, because 10 divided by 5 is 2. And finally, another one is 5 plus 1 equals 9 minus 3. Now notice this equation has two numbers on the left side and two on the right side. As long as they're both equal, because 5 plus 1 is 6 and 9 minus 3 is 6, then all is good with this equation. So a numerical expression doesn't have an equal sign, but an equation does. And that's the only difference between a numerical expression and an equation. Let's look at some more terms. We have constant and we have variable. Now, a constant is a single number whose value does not change. We'll look at examples later. And a variable is a letter used to represent an unknown number. The value of the variable can change. Now, don't think too much about how that works. We'll explore that later, but just think of it as a mystery number. It's a number you don't know. So if we look at this, x plus 5 or y minus 4, x would be our variable and 5 would be our constant because it's just a number whose value doesn't change. And for this one, y minus 4, y is our variable. That is correct. And 4 would be our constant. So make sure you label that. Let's look at some more terms. We have algebraic expression. So we learned about numerical expressions. What's an algebraic expression? An algebraic expression is a mathematical expression, so remember, a mathematical sentence that contains a variable. So 1 plus 1 would be a regular numerical expression. X plus 1 would be an algebraic expression. And what makes it algebraic is that it has this variable right there. Another example would be a minus b. Notice it has two variables. Or you can have n. It's a single variable, but yeah, that's an algebraic expression. Or 3r plus 4. Now 3r just means 3 times r plus 4. So those are all examples of algebraic expressions. They all have variables in them. And finally, let's look at the term term. What does term mean? Term is a single number or variable or number and variable together. So, for example, number and variable multiplied together. So, for example, 2x is 2 times x. That's a term. Y, that's also a term. And 4 right here, that's considered a term. So it could be a number, like 4, it can be a variable like y, or it can be a number and variable multiplied together, like 2 times x, right here, 2x. So you try these. Count the number of terms in each expression. How many terms are there in this numerical expression right here, 4 plus 9? Well, there's 4 and there's 9. So that's 2 terms. How about number 2? How many terms are here? Well, we have x, we've also got 5, and we've also got 3. So that's 3 terms. Now, how can you tell? Actually, let's go to number 3. How many terms do you have right here? Is it 0? No, it's 1 because that variable counts as a term. Number 4 gets a little bit tricky. So how many terms do we have here? 2x counts as a term. Y is another term. 3 is another term, and 1 is another term. So that is a total of 4 terms. So how can you tell terms from not terms? Well, you'll always have a plus or a minus in between the different terms. So notice like this has two terms and you've got a plus between it. This has three terms and you've got a plus and a minus. So the different terms are always separated by a plus or a minus. And finally, number 5, how many terms? It's not two, it's just one term right there. One term. Let's try some more examples. Create the following expressions or equations. So you can try this on your own. Can you create an expression with 3 terms? Now, it could be any kind of expression you want. I've got one. 1 plus 2 plus 3. Now notice, we have 3 terms. They're separated by plus signs. But if you wrote something like a plus b plus c, that's fine. Now, that's an algebraic expression, but still an expression. You could have done 5 minus n minus 3. Or you could have done 7m minus 8n plus r if you were feeling fancy. But notice I have 3 terms. 7m is a term, 8n is a term, and r is a term. And they're both separated, or they're all separated by like these pluses and minuses. So you could have had any number of terms or expressions. So write an expression with 5 terms. How about 1 plus 2 plus 3 plus 4 plus 5? I've got 5 terms. Now, if you decided to use letters or variables, you could have done that as well. You could have had minus signs or plus signs. Now, if you put division symbols or multiplication symbols between these, that would not make them separate terms. Only pluses and minuses. Let's try number 8, an expression with a variable and a constant. Ooh, they're being specific now. Now, what's a variable? A variable is a mystery number represented by a letter, and a constant. A constant is just a number. So we need a variable and a constant. So one variable and one constant. There you go, x plus 1. But you could have done 20 minus y, or any number of expressions. Let's try 9, an expression with 2 variables and a constant. So let's see. 2 variables, well, that could be like a and b, or x and y, and a constant. A constant is just a number. So I could do x plus y plus 1. And that would be 2 variables, x and y, and a constant, 1. You could have also said a plus b minus 5, or 2a minus 5b plus 3. Any of those would have worked. Let's try number 10, an equation with 3 constants. So this is a little bit different. All of these, 6, 7, 8, and 9, were all expressions. They're asking for an equation now. And remember, the difference between an expression and an equation is that an equation has an equal sign. So let's do 3 constants. 1 plus 2 equals 3. So we have a constant here, a constant there, and an equal sign. And then a third constant right there. You could have had any number of equations. You could have had 10 equals 5 plus 5. Now, 5 and 5 are still considered different constants, even though they're both the same number. You could have done 3 minus 3 equals 0. That's also an equation with 3 constants. Let's try number 11. By the way, if you got something completely or something different from these, that could be a right answer as well. Anyway, let's do the last one, an equation with 2 constants and a variable. So we still need to make an equation. It still needs to have an equal sign, but this time we need 2 constants and a variable. So how about 1 plus 2, that's 2 constants, and a variable equals x. Yeah, 1 plus 2 equals x is an equation with 2 constants and a variable. How about 9 minus 2 equals x? Or a plus 5 equals 8 is also an equation with 2 constants, 5 and 8, and a variable, a. Or 2 equals 6 minus c, also an equation with 2 constants, 2 and 6, and a variable, which is c. So now we know all about expressions and equations, and you can go ahead and get this and start applying it to some problems. Good luck.